Hello and welcome Math 45 students. I'm your instructor, Cindy Enrique, and we are going to go over Chapter 1, and in particular Section 1.1, which is the real numbers and algebra essentials. So the first thing that we're going to start with is the sets of real numbers. So natural numbers, what are they? Well, they are the numbers that you naturally count with. So for example, a natural number. You may want to naturally count, let's say, how many M&Ms are left in your bag. So you start with 1, and then you keep counting 2, 3, 4, and you just keep going. So some examples of some natural numbers are, like 45. I think people enrolled in this course are able to count to 45. And also, even though it's not natural to say the square root of 25, hopefully everybody knows what is the square root of 25. The square root of 25 is 5. So the value of the square root will be natural. Just as 14 divided by 2, we never count 1, 2, 3, 4, 5, 14 over 2. But what we do know that the expression 14 over 2, that simplifies to 7. And 7 is a natural number. So we always want to make sure that the simplified expression, whether or not that would be considered natural, okay? So let's go on to our next set. The next set would be whole numbers. So what's different with the whole numbers and the natural numbers is one single number. So what's that number right before 1? It's neutral. It's not positive, it's not negative, so that would be 0. So 0 is not positive, not negative, it's neutral. And it comes before 1. So that is the only addition of numbers with our whole numbers. So if we're still thinking about examples, then maybe we'd be thinking about, 0, 86, or even 2 to the third power, because 2 to the third power, would be 8, okay? And now for our next set, let's say we are going to be talking about integers. So if we talk about integers, well, we talked about the natural and the whole numbers, which add 0. So what are the numbers before 0? Well, that would be all of your negative numbers. So you'd have like -10, -9, -8, right? So let's just start with -2, -1, 0, 1, 2. And these are infinite in both directions, right? You can get to -100 or -10,000 or -100 million, right? So some examples could include 0, -10, maybe the square root of 25, okay? So these are just my negative numbers, my positive numbers, and 0. Now, if I'm thinking about my rational numbers, well, my rational numbers is going to be written slightly different. It's going to be written as a fraction. So I'm going to say that the rational numbers are P over Q, such that P and Q are integers. And of course that our denominator Q cannot equal to 0, because whenever I have division by 0, that would be undefined. So maybe you're like, hey, I don't really understand what you said. Like, say that to me in English. Well, any fraction can really be written as a decimals. So rational numbers, oops, sorry there guys. So our rational numbers can be written as decimals that follow two different rules. One, it repeats, or the second thing is that it terminates. So an example of a decimal that repeats could be something like, I don't know, 1.242424. So that 2424 keeps repeating. Another example of a decimal that terminates can be one that just stops. Like we know 1.5, and there's no other digits behind that 5. So that stops, so it terminates, okay? And so some examples of rational numbers can include the following. It can be a 1/2, because 1/2 can be written as a 0.5, so it's a decimal that terminates. We can also have 3/4, that's 0.75. We can also have -8, okay? We can also have a 0.25, and we can also have a 0.1 with the 1 repeating, okay? Now, an irrational number. So if I'm thinking about an irrational number, it's any number, let's say x, such that x is not rational. And again, if you're thinking, Cindy, can you please give that to me as in English? Well, these are decimals that don't repeat and don't terminate. So, for example, a number that does not repeat and does not terminate is pi. So we might estimate pi to be 3.14, but when you actually plug pi into your calculator, it's 3.141592654, and if your calculator has a lot of memory, it'll keep going and going and going. I believe, there's 100 decimals of pi, 100 million decimals of pi. It's never ending. So pi just keeps going on forever and ever, and there's actually no repetition with it as well. Another number that would be non-repeating, non-terminating would be the square root of 2. The square root of 2 is a decimal that does not terminate and does not repeat. Okay. So, for example, in this box, it says list all the elements that belong to the corresponding classification. So here are a group of numbers that we are going to classify. So what things do we know? Well, we know that the square root of 169, hopefully you guys know that. If you plug that into your calculator, the square root of 169 is 13. So that's nice. And the square root of, let's say, 24 is that 4.8989. And for this one, this 4.76376, this one looks like it's repeating. So this is 4.763, and then it repeats again, 763, 763, 763. So you can look at it as 763, 763, 763. So it repeats every third decimal, okay? And if I have -35 divided by 7, that's actually going to be -5. So sometimes it's just a good idea to kind of figure out what everything is simplified to, so that way you can organize it. So the only number here that's a natural number, remember how you naturally count things. So maybe I'll even put in here numbers that you count to help me remember. Well, the only number here that I see that I can naturally count up to, I can count to 1, 2, 3, 4, all the way up to the number 13. So 13 is going to be my only natural number, except it's not listed as 13 now, is it? It's listed as 169. Okay, so that's a little bit better. It's listed as the square root of 169. Alright, so now our whole numbers. So I know if it's a natural number, it has to be a whole number. So the square root of 169 will definitely be in there because that's 13. And the other number that I'm going to put as a whole number is, well, 0. Okay? So now we have 0 and 169. So, okay, done that. Now I want to think about my integers. So I have my natural numbers and my whole numbers and all the negative numbers as my integers as well. So I know that -5 is an integer, but the way it's written as my set is a -35/7. I'm going to just write that a little bit nicer. So -35/7 will definitely be in there. 0 is also an integer. I have the square root of 169, which is really 13, as an integer. This decimal, that's not an integer, and the other one is a decimal as well, so not an integer. Okay, so I have 3 things as my integers. Now, I'm going to go down to my rational numbers. So remember, my rational numbers are going to be defined as my decimals that terminate, so they terminate, or they repeat. Okay, so let's go at this again. So -5, yep, -5 is, you can think of it as -5.0, so I definitely have -35/7 as a rational number. 0 is a rational number. The square root of 169 simplifies to 13, so that's a rational number. Now the square root of 24, let's look at that. It's 4.8989799486. So none of those is a repeating pattern. Like, I cannot guess what the next decimal is going to be after the 6. Okay? So that is actually going to be an irrational number. There's no reason or rhyme to it, so I can't write it down. So now I'm going to look at the next one, that 4.763. Well, that's repeating. It repeats in chunks of 3. Like, if I were to guess the next decimal after the 3, it would be 7. After that would be 6. After that would be 3. So I can definitely guess it. So that 4.763, and that's a bar over it to let me know that those 3 digits are repeating. And I'll even write it smaller, so that way you can really see the difference here. So it's that 763 with a bar over it, okay? So then the only irrational number that I'm thinking about here is going to be that square root of 24. That's the only one that doesn't repeat and doesn't terminate, okay? So, of course, all the real numbers, well, all the real numbers would be everything. So everything would be listed as a real number. So, since I'm going to be listing everything, it would be the -35/7, the 0, the square root of 169, the square root of 24, and that 4.763 that's repeating. Okay. Well, I hope that helps. And now we're going to go on to the page 2. So page 2, we are going to be going over our order of operations. So order of operations, you may have been taught that this is referred to as "Please excuse my dear Aunt Sally," or PEMDAS. So I just want to be careful because it does say P for parentheses, but really it's any grouping symbols. So yes, of course, parentheses are a grouping symbol, but so are brackets, and so are braces, and so are absolute values, okay? And so are fractions, and so are square roots. Okay? So all of those represent our grouping symbols. And of course we have E for exponents, and it's multiplication or division, whichever comes first from left to right. And we have addition or subtraction, whichever comes first from left to right. So what we do is we are going to use our order of operations to evaluate each of the following expressions. So what do we have? We have part A. It says 3 times 2 squared minus 4, 6 plus 2. So it looks like the first thing, if I'm following my order of operations, is I'm going to do the inside of the parentheses. So I see that I have parentheses here, and I have parentheses here. So that's the first thing I'm going to be dealing with. So I'm going to do the operation inside, 3 times 2. That would be 6. And it's squared. Minus 4 times, now I'm going to simplify the inside of this as well. 6 plus 2, that's going to give me 8. So even though I simplify the inside of the parentheses, I'm going to leave it there because it's multiplication with the 4. I don't want to drop it until I actually complete the multiplication. So now this is saying 6 squared minus 4 times 8. So in order of operations, the exponent is going to go second. So now this exponent, 6 squared, that's going to be 36. 6 times 6 is 36, minus my 4 times my 8. So now from our order of operations, the next thing that comes along is multiplication. So multiplication, I have 4 times 8, which is going to give me 32. So 36 minus 32 will give me a 4 for my final answer. Okay, so now for part B, again, we're going to be applying our order of operations, okay? So it looks like I have a couple of things going on. I have a fraction and I have a square root. So I'm going to deal with the fraction separately than I will with the square root, okay? So here, I'm going to try to simplify the numerator. I have my denominator, and I also have the inside of the square root. So, okay, if I'm thinking about my numerator, I'm going to write that in one color. I'm going to say that that's going to be my 5 squared minus 4. Down at the bottom, I have 7. That's not going to change. And I also have the square root, and now I can I can simplify the 11 minus 2. 11 minus 2 is going to give me 9. So now what I want to do is I want to look at that fraction, and I definitely want to simplify that first numerator. So that numerator, I have exponent and I have subtraction. So the thing that's going to kind of come first is going to be the exponent. So I'm going to have this as 25 minus 4 over 7 minus the square root of 9. So now when I simplify, I'm going to have 21 minus 4. So 21 minus 4 is going to give me a 21 over 7 minus the square root of 9. And now I can simplify this a little bit further. So 21 divided by 3, that's going to be 3. The square root of 9 is 3. So 3 minus 3 is going to give me 0. So my final answer here is going to be 0. 3 minus 3 is equal to 0. Okay, well, I hope this is helping. So for part C, I'm still doing the order of operations, and what I see is my absolute value. So absolute value is a grouping symbol, just like parentheses is a grouping symbol. So I'm going to do my grouping symbols first. So I'm going to have my 6 minus, so I'm going to simplify the inside. 5 minus 8 is a negative 3. And I have plus 3, that's being multiplied, and 4 minus 1 is going to give me 3 as well. Okay, so now I still have sort of like a grouping symbol, and that would be the absolute value. So with that absolute value, I need to think about what this is going to be. So I'm going to copy down what I have. So I have 6 minus, so now if I think about the absolute value of negative 3, well, visually, if I want to think about it, here is 0, negative 1, negative 2, negative 3. So if I were to say, to get from -3 to 0, I would go 1, 2, 3 spaces. So the absolute value of -3 is 3. Okay? And I have plus 3 times my 3. So the next thing I want to think about is multiplication. So 3 times 3. So I'm going to have 6 minus 3 plus, and 3 times 3 is going to give me my 9. And now doing my addition and subtraction, whichever one comes first. So what comes first here is going to be subtraction. So I'm going to do my 6 minus 3 as 3 plus my 9. And 3 plus 9 will give me my final answer of 12. Okay, and now for part D, order of operations again. So I'm going to look for my grouping symbols. So I have this. And now I also have something else. So I have this grouping symbol with brackets, which is all of this. And even within that, I have my parentheses. So what you want to do with order of operations, if you have, let's say, 2 sets of grouping symbols within each other, you want to work from the inside to the outside. So let's check this out. So I'm going to have 7. And here, I'm going to have my 5 times 3, which is a 15. And I'm going to have minus 2 bracket. And my parentheses, since I'm working from the inside to the outside, 6 minus 3 would be 3. I have minus 4 squared plus 1. So I still have my grouping symbols. That would be my brackets there. So I'm going to go ahead and copy that down. So 7 times 15 minus 2. And on the inside here, I'm going to work from the inside. And I'm going to have to simplify that squared first. So I'm going to have 3. And you can put it with or without parentheses. You can drop it now. And minus 4 squared is 16. So almost done simplifying inside the parentheses, except now I need to do my 3 minus my 16. So 3 minus 16 is going to give me a negative 13 plus 1. And now the parentheses or the brackets, what they represent is actually going to be multiplication. So I'm going to have this as my 7 times 15, which is 105, minus, and then 2 times negative 13, that is going to give me a positive 26. And I still have a positive 1. And it was a positive 26. There we go. Because negative 2 times negative 13, a negative times a negative is a positive. So 2 times 13 is a positive 26. And now I can add these together. So 105 plus 26, well, that's going to give me 131 plus 1, which will give me 132. Okay. So hopefully this is all kind of a flashback from things you've learned maybe in your last math class, or things that you've learned a while ago, that's still kind of, that you needed a refresher on, okay? Alright, well, the next thing we're going to be doing is using our calculator to help us find some values. So here it says, use your graphing calculator to find the following. Round to the nearest thousandths place. So that's the most important sentence here, is round to the nearest thousandths place. You might be thinking, oh man, how do I round? I kind of forgot. Well, I can write my notes over here to the side. So when rounding, there's basically going to be two rules. If you have 5 or above, or let's say higher, you're going to round up. If you have below 5, then you're going to round down. And if, let's say, you're not really sure about this thousands place, well, that thousands place, that THS, tells you that it's behind the decimal. So let's think about this. So if I had my decimal, then I would have the tenths, hundreds, thousands place. So over here, that's my ones. This is my tenths. This is my hundreds. And this last one over here would be my thousands. So when I'm rounding, the one behind the thousands is the one that we're going to be looking at. So I do apologize, I'm not the best drawer, but this is to kind of signify that this is the one you look for, and it's going to influence whether you round up or round down when you calculate the answer. Okay, so hopefully you are now all familiar with rounding, okay? So this is where you're going to have a calculator. Of course, any calculator would work for these problems, but I do want you guys to get comfortable with your TI-84 plus CE calculator. That is the calculator that is required for this course. So I'm gonna go ahead and pop up my calculator. So right now I have a trial version. So this is what I have. So I'm going to plug in the square root of 38. So notice how the square root is kind of blue and it's little. So I'm going to go to second. Notice how once I press second, it's now red, okay? Now I'm going to go to that square root. So whenever I press a button on the calculator, if you're following along visually, the button turns red. And now I plug in 38. And I'm going to press enter. And so when I do that, I get that 6.1644140003. So I'm going to go ahead and write that down. So I had my 6.1644140003. And again, I'm looking at my thousands place. So I'm going to look at 4 decimals past. 1, 2, 3, 4. This is where I'm going to be looking. So 1, 2, 3, 4. So this is the 4th digit that's going to be influencing the digit before that. So here, because 4 is below 5, that means I'm going to round down. So that means by rounding down, I leave it alone. So when I round down, it's 6.164. That would be my final answer. Okay, so now I'm going to go to part B, and I'm going to plug that into my calculator. So for this one, notice it's not just a regular square root. Now it's a 4th square root. So in order to do a 4th square root, I'm going to have to plug this into my calculator delicately. So here, I'm going to go to my math, and I'm going to scroll down to number 5. So once I'm at number 5, it gives me the index that I want to be calculating. So instead of a square root or a 3rd root, in particular for part B, it's going to be a 4th root. So I'm going to go ahead and click that option. So I'm going to put my 4 in. And then inside the calculator, I'm going to plug in my 13. So I'm going to get that 1.8988289. So I'm going to go ahead and plug that and write that down so that way we can see it. So I'm going to go to my 4th digit. And so because that digit is 8, it's higher than 5. So that tells me I'm going to round up. So I'm going to bump up that thousands place. So I'm going to rewrite it as 1.89. So this digit of 8, I'm going to bump it up to 9. So it's 1.899. Maybe I'll write that a little bit nicer. There we go. So 1.899 when rounding to the correct thousands place. Now I'm going to do the exact same thing with part C. So part C, I'm going to go back to my math. And I'm going to go down to my option number 5. So I can plug in my 6th root. And it's the 6th root of 192. Okay, so now that I have that, I'm going to press enter. And I have that 2.401873691. So I'm going to go ahead and write that down. So that this was a 2.40187391. And so I'm going to go over to my 4th digit behind the decimal. That's this one, 8. And it's going to tell me what to do with that thousands place. Since 8 is bigger than 5, that means I'm going to bump up that 1. So I'm going to rewrite it as a, oops, let's use a different color here, as a 2.402. So that is how I'm rounding to the nearest thousands place. For part D, I know it can look a little intimidating because now, wait a minute, it's not just a single entry in my calculator. Now I have pi, I have square, and I have parentheses. Well, don't worry, we have a graphing calculator, so it's really nice and smooth to go ahead and do that transition. So let's go ahead and do this together on our calculator. So we have 4. The pi button is here, so I'm going to go to second pi, okay? And the square button is the one that says x squared. So that will square whatever you have. So now it's plus 5 parentheses, and I have a 6.17, and close your parentheses. So now I've entered it into my calculator. And the really cool thing about these calculators is that it does order of operations for you. So as long as you know how to enter it into your calculator, it should pretty much give you the right answer. So I have that 70.3284176. So I'm going to go ahead and copy that down as a 70.3284176. So I'm going to be looking at the place value of the thousands and the one right next to it. So it's the tenths, hundreds, thousands. This is the one behind the thousands. So that's going to tell me how to round. So here, because that 4 is smaller than 5, then it tells me to leave the 8 alone. So I have 70.328 by itself. And unfortunately, sometimes my notes, I write them all by hand. Well, actually, I collaborate with another instructor. The other instructor is Natalie DeMoss. We do very similar lectures, very similar styles. And we actually did this one incorrectly. So I'm going to go ahead and just say that there's an error. It turns out to be negative inside the square root, and we haven't really taught you that yet. So this problem would be better in a later chapter when we deal with negative numbers. But as of right now, you don't know how to calculate a negative square root, which would be an imaginary I. So we'll get to that later. Not in the first chapter, but in the later chapters. And now we have our part F. So part F, we have a fraction. So to enter a fraction, I'm going to go to second, and then math. Nope, sorry, hold on, give me just a second. Okay, so to enter the calculator, I'm going to go to alpha and go to my y equals. So notice how these are going to be my different settings for my fractions. So I want the numerator divided by my denominator. So that's going to be my first option. So I'm going to go ahead and press enter. So now I'm going to have that pi. So I'm going to go to second pi minus my 17 times 9. And down at the bottom, I have 4 to the power. The power button is right before the, or right above the division sign. So 4 to the 5th power. And now I have a plus 15. So when I press enter, that is going to be the number that I get. That negative 0.144423. So I'm going to go ahead and write that number down as well. So I have a negative 0.14423338. So if I'm looking at the thousands place, tens, hundreds, thousands, it's that 4. So that 2 is going to determine what to do. So because it's a 2, that means it's less than 5, so I leave it alone. So my final answer here is going to be a negative 0.144 as my final answer. Okay, well, I hope that helps you guys. And that is the end of section 1.1. And that's all that we have in chapter 1. So if you guys have any questions, please feel free to email me. Thank you.